These are the 12.2 notes for trig. We're going to talk about finding the magnitude and direction. We already did magnitude, so this will just mostly be focused on direction. So in order to find the exact direction, we're using this formula, and that formula should look pretty familiar to you. It used to look like tangent equals y over x, which we did all last unit. So these values are not going to be on the unit circle, so we're going to have to use our calculator, and the calculator will need to be in degree mode. So take a second, change your calculator over into degree mode. There we go. And the calculator is designed to give answers from negative 90 degrees to 90 degrees. We don't want that. We want our answers from 0 to 360. So in order to adjust the calculator, after we get that answer, we're going to have to follow this chart over here. So you can see in quadrant 1, you're going to use the angle from the calculator. In quadrants 2 and 3, you're going to add 180 degrees to the answer from the calculator. And in quadrant 4, you're going to add 360 degrees. Let's see what that looks like. Example 1, we'll do tangent of theta equals b over a. And then in my calculator, I'll type in inverse tangent of 5 over 1. So inverse tangent, shift tangent, or second tangent, 5 over 1. 5 divided by 1 will get me 78.69 degrees. I'm going to go ahead and round that to 79 degrees. And then I have to check to make sure which quadrant it's in. So if you think about the vector 1, 5, it starts in the center because it's in component form and goes over 1 and up 5, and it looks like that. You can see that's in quadrant 1. So 79 degrees would be my final answer. 79 degrees is between the 0 and the 90 degrees. That represents quadrant 1. All right, for example number 2, I usually skip this first part here, and I just go to what's going to go into my calculator. So I'm just going to type it in as 4 over negative 2, save myself a little writing step. We'll type it in, inverse tangent, 4 divided by negative 2. Make sure you type the negative button, not the minus sign. And we get an answer of negative 63.4349, etc. I'll round that to negative 63. Now, let's take a look at where this vector would be. Starts in the center, negative 2 left, up 4. We are in quadrant 2. So our answer needs to be between 90 and 180. So anything in quadrant 2, I'm going to add 180 degrees to the answer from my calculator. So I'll add 180 to this to give me an answer of 117. Example number 3. Again, negative 7 over negative 3, b over a. Type that into the calculator. Get 66.8. We'll round that to 67 degrees. 67 degrees. Let's take a look at where our vector is. It starts in the center, component form, and goes left 3, down 7. So we know it's in quadrant 3. So according to the chart, we'll have to add 180 degrees to that, which gives us 247. Which makes sense because this is 180 degrees and this is 270. So we know our answer has to be between 180 and 270 in order for it to be in quadrant 3. Example 4. Oops. Inverse tangent of negative 2/5. Type that into the calculator. Negative 22, let's round that to negative 22. Let's see which quadrant it's in. Starting in the middle. All right, sorry about that. So this one is in quadrant 4. Positive 5, negative 2 would put me about right here for my vector, which means my answer has to be between 270 and 360. So negative 22 isn't going to cut it. Quadrant 4 in the chart tells me to add 360, and that'll give me 338 degrees. All right. On the backside, all we're doing is adding the magnitude to the direction. So these are two completely separate steps. They don't have anything to do with each other. So we'll set up the magnitude as this equation right here. So we'll do the square root of a squared plus b squared. It's already in component form, so we're good. We don't have to convert it over. That would be 36 plus 64. Add those to make 100, and then take the square root of that. So the magnitude would be 100, meaning the length from 0, 0 to 6, negative 8, that length would be 10. All right, now we do the direction. Inverse tangent of negative 8 over 6. Type it into the calculator. I've done that several times. I'll just go ahead and write the answer here. Negative 53 degrees. It's in quadrant 4. So we're going to add 360 to that, getting us 307. At the end, when you get your direction, double check to make sure it makes sense. Here's 270 degrees, and here's 360. And we know it has to be between those two numbers, and 307 is definitely between those two numbers. If it's not, go back and check your calculator or check what you added. Example number 6, similar thing. Square root of 34, it is not a perfect square, so I'm just going to go ahead and leave it as a square root of 34. Let's figure out where this vector is. Starts in the center 0, 0, and negative 3, 5. Somewhere up there, right? So we know it has to be between 90 and 180. I'll type it into my calculator. I get negative 59 degrees. Obviously not the answer we want. So we're going to add, according to the chart, add 180 degrees because we're in quadrant 2, which gives us 121 degrees. That looks much better. That's definitely between 90 and 180. All right, down at the bottom, I'm actually going to have us graph this so we can see what's happening. So we're going to graph, let the vector v have an initial point at 7, negative 6. So 7, negative 6 would be right here. And then a terminal point, which is where the arrow is, at 5, negative 1. That's my vector. We don't love vectors that are kind of off in space. We like them centered here. So I'm going to think, how did I get this dot, this initial dot, to the origin? It looks like I moved left 7 and up 6. So I'm going to take this little dot here and move it left 7 and up 6. And it takes me to right there. And then you kind of moved that vector. On Delta Math, it's nice you actually get to drag it, but since we're working on a piece of paper here, we don't. So the component form, once it's centered at 0, 0, it's in component form. So wherever this point is, that arrow is my component form, negative 2, 5. And then from the component form, we get to do the magnitude the same way we always do. Square the a as well as the b. And get the square root of 29, which is not a perfect square, so I'll leave it in square root form. And then the direction, 5 over negative 2. That's a terrible negative 2, sorry about that. Which gets me negative 68 degrees. You can see over here that that's in quadrant 2, so I'm going to add 180 to that to get an answer of 112 degrees.